Hey, welcome to the Explainer. Today, we're going to talk about your code's most valuable data and the professional gatekeepers that are built to protect it, getters and setters. So, to really get why we need them, let's just imagine a world for a second. A world with absolutely no data protection whatsoever.
I mean, what happens when any part of a program can just directly read and, maybe more importantly, change your data without any rules or anyone watching? Well, it leads to total chaos.
Just take a look at this simple user class. You see that age variable? It's marked as public. That's basically like leaving the vault door to your bank wide open. Anybody can just stroll right in and do whatever they want with what's inside.
And because age is public, some other part of the code can just set it to a completely impossible value, right? Like -99. The user class itself is totally powerless to stop this from happening, and that is a huge, huge problem for keeping our data reliable.
So how do we fix this mess? Well, the solution is in this core programming principle that is just absolutely fundamental to good software design. It's called encapsulation. Think of it like this. Instead of just leaving your valuables out in the open, you bundle them all up, you stick them in a safe, that's the class, and then you control who gets the key. And the key, that's the public methods that you decide to create. So the crucial point here is we protect our data by making it private, basically locking it away from the outside world. And then we build a controlled public way for other code to interact with that data. And this right here, this perfectly shows that shift in thinking. We're moving away from this idea of unguarded data, which is just fragile and unsafe, to a managed, controlled system that gives the class full authority over its own information. So how do we actually build this controlled access? Well, we use a pair of special methods that act as our gatekeepers. You guessed it, getters and setters. It's a really simple and honestly kind of elegant system. The getter's job is to retrieve the data for you. The setter's job is to let you change the data, but, and this is the most important part, it only lets you do it according to the rules that we define inside that method. Here is a classic example. The count variable is now private. You can't directly touch it anymore. To read its value, you absolutely have to call the public getCount method. To change it, you have to use the public setCount method. We have now established control. Now, what's really cool about this whole thing is that our gatekeepers can be incredibly smart. They aren't just simple doors that open and close. They can enforce some really complex rules and logic. Okay, let's upgrade our example a bit. In this person class, we have a private name, and we want to make sure that any name assigned to a person is always a valid, a sensible name. This setName method, it's basically our bouncer at the club door. Before it actually changes the internal name variable, it checks two things. Is the new name not null? And is it longer than 2 characters? If either of those checks fail, nope, the invalid data gets rejected. It never even gets in. And this logic, it works on the way out too. The getter can prepare or format the data before it even hands it over, making it way more useful or more secure. Look at this modified getName method. Now, if the name that's stored is longer than 16 characters, instead of returning that raw, super long name, it returns a user-friendly message. The getter is actually formatting the output based on some internal logic. Pretty neat, right? Now, for this whole system to work well, especially on big projects with lots of developers, programmers follow a standard naming convention. You can think of it like a professional protocol or a kind of secret handshake that everybody on the team understands. And the convention is beautifully simple. For most variables, the methods are just named det or set, followed by the variable's name, written in what we call camel case. The only little twist is for Boolean variables. For those, we typically use is for the getter, because it just reads more naturally, Is available just sounds better than get available. So, to wrap it all up, using getters and setters give you 3 massive advantages. First, protection. It makes sure your data stays valid. Second, flexibility. It lets you change your internal logic without breaking everyone else's code. And finally, control. You get to decide exactly how your data is read and written. At the end of the day, when you embrace encapsulation with getters and setters, you're not just writing lines of code. You're actually designing robust, maintainable, and secure systems. You're putting smart, reliable gatekeepers in charge of your most important assets.